Hello everyone. This is the video lecture for the topic Local and Optimization Problems for the first unit of Artificial Intelligence and Machine Learning. The objectives are to study the various local and optimization problems and to apply these kind of problems. Hill climbing algorithm. We are going to see one algorithm in this particular concept. Hill climbing algorithm. It is a local search algorithm which continuously moves in the direction of increasing elevation or value to find the peak of the mountain or best solution to the problem. It terminates when it reaches a peak value where no neighbor has a higher value. It is a technique which is used for optimizing the mathematical problems. One of the widely discussed examples of hill climbing is traveling salesman problem, in which we need to minimize the distance traveled by the salesman. It is also called as greedy local search. It only looks for good immediate neighbor state and not beyond that. A node of hill climbing algorithm has two components, which are state and value. It is used when a good heuristic is available. Features of hill climbing. The following are the main features: generate and test variant, greedy approach, no backtracking. Hill climbing is a variant of generate and test method. Generate and test method produce feedback which helps to decide which direction to move in the search space. Greedy approach. Hill climbing algorithm search moves in the direction which optimizes the cost. No backtracking. It does not backtrack the search space as it does not remember the previous states. State space diagram for hill climbing. A state space landscape is a graphical representation of the hill climbing algorithm, which is growing graph between the various states of the algorithm. In the y-axis, on y-axis we have taken the function which can be the objective function or cost function, and state space on the x-axis. If the function on y-axis is cost, then goal of the search is to find the global minimum and local minimum. If the function of y-axis is objective function, then the goal of the search is to find the global maximum and local to find the global maximum and local maximum. This is the search space for the hill climbing problem. So the y-axis represents the objective function. There is a graph. Here each point represents the states. So the aim is to reach the global maximum. And somewhere there will be the highest point when compared to the neighbor. It is called as local maximum. In some places all the states will be of the same value. That is called as flat or flat local maximum. Local maximum is the state which is better than its neighbor states, but there is also another state which is higher than it. Global maximum is the best possible state of state space landscape. It is the highest value of objective function. Current state, it is the state in a landscape diagram where an agent is currently present. Flat space. Flat space is a landscape where all the neighbor states of current states have the same value. There are three types of hill climbing algorithms: simple hill climbing, steepest-ascent hill climbing, and stochastic hill climbing. Simple hill climbing, it is the simplest way to implement a hill climbing algorithm. It only evaluates the neighbor node state at a time and select the first one which optimizes the current cost and set it as a current state. So the algorithm is, first step, evaluate the initial state. If it is a goal state, then return success and stop. Step 2, in loop until a solution is found or there is no new operator left to apply. In step 3, select and apply an operator to the current state. In step 4, check the new state. If it is a goal state, then return success and quit. Else, if it is better than the current state, then assign new state as a current state. Else, if not better than the current state, then return to step 2. Second type of hill climbing is steepest-ascent hill climbing. It is a variation of hill climbing algorithm. It examines all the neighboring nodes of the current state and select one neighbor node which is closest to the goal state. This algorithm consumes more time when compared to the simple hill climbing algorithm. So in the algorithm, the first step is it will evaluate the initial state. If it is the goal state, then return success and stop. Else make current state as the initial state. In step 2, loop until a solution is found or the current state does not change. Let SUCC be a state that Any successor of the current state will be better than it. For each operator that applied to the current state, apply the new operator and generate a new state. Evaluate the new state. If it is a goal state, then return it and quit. Else compare it to SUCC. If it is better than SUCC, then set new state as SUCC. If the SUCC is better than the current state, then set current state to SUCC and exit. So this will be repeated until to reach the goal state. Stochastic hill climbing. This is the hill climbing which does not examine for all its neighbor before moving. Rather, this search algorithm selects one neighbor node at a time at random and decides whether to choose it as a current state or examine another state. There are three problems in hill climbing algorithm. Local maximum. It is a peak state in a landscape which is better than each of its neighbor state, but there is another state also present which is the higher than the local maximum. Solution for the local maximum is backtracking technique. So this is the local maximum. So the algorithm will take this is the goal state, but this is only the local maximum. There is another one state is there which is actually the goal state. Plateau. Plateau is the flat area of the search space in which all the neighbor states of the current state contains the same value. Because of this, algorithm does not find any best direction to move. Solution is to take big steps or very little steps while searching to solve the problem. This flat area is called as plateau. That is, all the neighbor states will have the same value. The algorithm will not find the way which direction to go to for the goal state. That confusion will be produced by this flat plateau. And the third one is ridges. A ridge is a special form of the local maximum. It has an area which is higher than its surrounding areas, but itself has a slope and cannot be reached in a single move. With the use of bidirectional search or by moving in different direction, we can improve this problem. So this kind of pattern is called as ridge. Simulated annealing. In hill climbing algorithm, which never makes a move towards a lower value guaranteed to be incomplete because it can get stuck on a local maximum. And if algorithm applies a random walk by moving a successor, then it may complete but not efficient. Simulated annealing is an algorithm which yields both efficiency and completeness. Annealing is the process of hardening a metal or glass to high temperature, then cooling gradually. So this allows the metal to reach a low energy crystalline state. The same process is used in simulated annealing, in which the algorithm picks a random move instead of picking the best move. If the random move improves the state, then it follows the same path. Otherwise, the algorithm follows the path which has the probability of less than 1, or it moves downhill and chooses another path. So that's all about the topic. Thank you.